Mathematics Analysis and Approaches, Paper 2, Timezone 1, HL, November 2025. This is question number 4, which carries 7 marks. He is given as a cost function here, and he is given as a graph of the cost function. Using that information, we need to find the value of A and B. He has told that there is a minimum point and then a maximum point over here. And we also are supposed to find a value for K such that this happens. In a way, he is asking for the period of the graph itself. When is the values repeating? That's the value for K. The function can also be written in the form of sine. So if I had to consider this to be the sine function, what is the horizontal translation, vertical translation, amplitude, and the period? And then that's what we're looking for. So from there, we're going to find a value for P and Q. All right. And this question can be solved by using the local minimum and the local maximum point. I can take this and substitute in this equation, and that should be giving me the value for A and B. For example, if I take the value for x is equal to 0 over here, I'll have a cos 0, and cos 0 is a 1, right? So if cos 0 is a 1, I can directly get the value. Let's actually do that. So I have y is equal to a cos bx, minus 3. A cos bx minus 3. And the point that it's passing through is 0, minus 8. So minus 8 is going to be equal to a cos 0. Cos 0 is going to be a 1, minus 3. And from here, you can see that I'll have a minus 5 as equal to a. So a value is a negative 5. Done. So I can write the equation now as y is equal to minus 5 cos of bx minus 3. So I can again take the maximum point here. The maximum point is 16,2. So I can go ahead and substitute that point. So 2 is going to be equal to minus 5 cos of 16b minus 3. Transposing it again, this is going to be a 5 is equal to minus cos of 16b. So cos of 16b is simply going to be a negative 1. 16b has to be equal to a pi, and that gives me the value for b as equal to pi by 16. And that's the end of it. So we got the value for a and we got the value for b. Very good, right? So this is one way of doing the question. If you wanted to use the idea of translation, which is important for you to know, it would be better if you actually learn that one. So let's say this is a sine of b times of x minus c and plus a d. Let's say this is a sine function over here. What happens? Let's actually look at the actual sine function on Desmos. Okay, I'm going to demonstrate each one of them to you. Again, if you don't want to learn about this one, you can fast forward and look at the remaining part of the solution. But people who want to understand how it works, please stick with it. So what you're seeing here is a sine function. You can see that the sine function has the maximum of 1, and that maximum is happening at pi by 2, and then a minimum of negative 1, which is happening at 3 pi by 2, and then the period of the function is going to be 2 pi, because after 2 pi, the function is simply going to repeat itself. All right, so that's your sine function. So if, also please note that the amplitude of this function is a 1. All right, the amplitude is a 1, which basically is the highest point it can reach. Yeah. In a way, you can think about amplitude as the highest point it can reach from the axis of the sine curve. And for this particular sine curve, the axis is the x-axis. Right, the principal axis, let's say. Okay, good. Now I'm going to take this sine curve and simply multiply this with, let's say, a 3. The moment I do that, what happens? The graph is stretching, right? So there is a vertical stretch, correct? And by how much is it stretching? Earlier it was simply a sine x. I'm going to go back, and earlier you could see that the amplitude was a 1. Now the amplitude is a 3. So the number here changes the amplitude, right? So the amplitude or the graph itself stretches with a scale factor of 3. That's how I can put this across. So let's go back and say, okay, so A increases amplitude or is connected to the amplitude, or I can say there's a vertical stretch by a scale factor of A. That's something that I can say. Okay, so what happens when I take sine x and let's say I'm simply adding a 2 to it, right? I simply added a 2 to it. So when I do that, what you will notice is the graph which started at 0, 0 has shifted to start from 0, 2. All right, it's the same graph which has moved up, right? So what I can say, if I wanted to make more changes to this, I can probably write a over here, and then I'm going to add a slider, so you can see that it's the same graph which moves up and down depending on the value for a. If the value of a is negative, there is a vertical translation downwards, and vertical translation you can say probably upwards, right? Or you can simply say there's a vertical translation of by d units. That's something that you can mention, right? Okay, great. So if that's the effect of the last number, let's go back and update that here. Let's see what this c value does. Okay, I'm going to go back to Desmos again, and remember the value c is inside of the bracket, so I'm going to say x minus, let's say, 2. Blue curve, which is the initial sine curve, has moved 2 units to the right. That's the effect. So this number, which is c, will have a horizontal translation. So d will be vertical translation and c is going to be a horizontal translation. So what does b do? Let's look at that one. Going back to Desmos again, and for this graph, remember b is outside of the bracket. It's not inside of the bracket. It's outside of the bracket of x minus c. All right, be careful with that. So if that is true, then what if I wrote this as 2x, sine of 2x? So the red one is the new graph and the blue one is the old graph. So let's look at the period of the initial sine function, which is 2 pi. What is the period of the new sine function? So when I say period, I'm looking at, okay, when is it going up, coming down, and then going up, basically the period. So you can see the new period is simply a pi. The old period was 2 pi. Or in a way, I can say that the graph has a stretch factor. But in this case, the stretch factor is not going to be by b, it's going to be 1 over b, because the amplitude, the period of the graph reduces. Okay, horizontal stretch. Can I answer these questions a bit more faster is what I'm thinking. So let's take the equation here. What he has given is y is equal to, so from here I know that there is a horizontal, a vertical translation of a -3, and there is no horizontal translation because there is no number after x over here, and therefore I can consider the function to be starting from the origin itself, x is equal to 0, and generally and the cos function starts from 0, 1, right? This is 0, 1, this point, and then it goes down. However, this is starting from a negative y-axis, and therefore the function will have a negative of a cos bx minus 3. So I know that this is the minimum point and this is the maximum point. And even in the cos function, this is the minimum and that's this is the maximum and this is the minimum, and that gives me the axis at 0, right, which is the midpoint of the minimum and the maximum. So I'm now going to find out the midpoint of the minimum and the maximum. So this entire length is going to be at 10, and 10 divided by 2 is going to be a 5, which means that the axis of the cost curve here is that, which is y is equal to minus 5. Y is equal to minus 5. Now, if that's the axis, what is going to be the amplitude? From here to here, of course, it's a 5. And sorry, this is not y is equal to minus 5, it's y is equal to minus 3. And from here to here, it's going to be a 5. So the amplitude is going to be a negative 5. Please bear that in mind. So either you can justify the negative like that, or you can come back here and say y is equal to minus 5 times of cos of bx minus 3. Because of the amplitude, it goes to a 5. It starts from a 1, goes to a 5, and then there is a shift of 3, and therefore it goes to a 8. But because it's negative, the graph is reflected, and therefore the point is now going to be here. Okay. So what is b then? So as I was saying, the cos function behaves like that. So this is going to be 0 to 2 pi. 0 to 2 pi, and somewhere the midway is going to be 0 to pi. All right. So the midway for this graph is 16, and therefore the period is going to be at 32. The period itself is going to be at 32. Into b is going to be 2 pi, so that means b is equal to 2 pi by 32, or b is simply going to be a pi by 16. So that's your value for b. So two ways of finding the value for b. One is this, and the other way is that you can choose whatever methods you want to. Learning this would be important because you may get questions based on this when you're doing modeling, right? So that's the solution for that. Let's look at the next part of the question. So write down the values of k. That's what it's asking for. Well, I already know that k is going to be at 32, so I can directly update 32 over here for k. Now, if I had to consider this function to be a sine function, I need to find a value for q. So let's now go back. Okay, so the function is f of x is equal to p sine bx, b times of x minus q minus 3. I know that the b value is pi by 16, which I found from the previous solution itself. Now, I know that the axis of this trigonometric curve is going to be y is equal to minus 3. Okay, and I also know that the sine curve actually starts like that and then goes down and goes up like that, and this curve is obviously having a vertical shift of a negative 3, and that's why this value is here. I now need to figure out, okay, what is going to be the horizontal shift, and then what's going to be the amplitude of the sine curve. Right now, from here, how much far am I going to the maximum or the minimum point? That's a question. The maximum or the minimum point that I'm going to is a 5. Now, the next question that I am going to be asking is if there has been a reflection, right? Then I'll have to consider the p-value as negative. As of now, I know that the p-value is a 5. Now, the next question is, has there been a reflection? There has not been a reflection simply because the curve has been shifted by q, right? There is a horizontal shift, and therefore the curve essentially could have started from here. It is possible. Maybe this point could have started from here, and that's a very possibility, and therefore I'm not going to take this as negative. So now I know that y is equal to 5 times, find the value for q, so I'm going to say minus 8 is equal to 5 times of sine of pi by 16, open parenthesis, 0 minus q minus 3. So that's minus 3 transposed to the left hand side. It's going to be a minus 5 here, and then 5 sine times sine of minus q pi by 16, and sine of negative theta is going to be minus sine theta. So that's minus 5 sine of q pi by 16. So negative and negative will get cancelled, so you will end up getting sine of q pi by 16 as equal to a 1, which means q pi by 16 is going to be a pi by 2. Pi will get cancelled, 2 ones are 2 8s. That will give me the value for q as equal to 8. Okay, so you can solve it in multiple ways. Probably substituting the values will be a bit more faster, you can do that. But if you did know how the translation, amplitude, vertical stretch and horizontal stretch works, the question becomes a bit more simpler in solving, right? That's it for this video.